It's unbelievable. He's very, very good. It's just unbelievable. He coded this sort of stuff in like 1 hour or something. It's unbelievable. Yeah, I would never be able to do that. But yeah, I do different stuff. I do crypto miniset. He's hacking crypto miniset to do this. So it's like it's a great collaboration in this sense. And so we come to the conclusion here. And one of the points that I try to demonstrate here is that set solvers are very powerful. And as you saw, there's plenty of tools around to understand what they're doing. And there's a competition organized every year. So it's not just the toys. It's actually being used by Intel. There's a lot of investment in this stuff by big companies, because once you're Intel, you really want your chip to be correct. And you know, if it takes $100,000 or $1 million, it's not a big deal, right? So it's pretty interesting from an industrial point of view. It's pretty interesting from a cryptographic point of view. The original work by Fabio Masacci, an Italian professor, was the one who started using set solvers for cryptography, and it worked out pretty well. But you know, he wasn't that much into set solving. I luckily was in between the two, so I was interested in one and the other, and so that's the reason why crypto miniset was born, and the reason why it's being developed right now. And if you want to join or understand or just be part of a community that is doing this, then you can come around. It's so you're all welcome. And actually, I would be really happy if you do. Crypto miniset is not a bad set solver. It won last year, which is a pretty big thing actually. I was very surprised. And this year, I think we're going to do good. I don't know how well we're going to do. Hopefully, we're going to be in the top 3. So I'm looking forward to some good results. And if you come around, you can be part of this result. I'm just a leading developer. It's not all my credit at all, because I'm just trying to find direction, and lots of people are contributing, and it's great. It's great. So if you're interested in hacking around, there's plenty of stuff to hack around. Crypto miniset is very low level, at the same time it's being very high level. So you can find your point of abstraction easily. And finally, going back to Hackito, yeah, don't use ciphers that you haven't tested or haven't had tested by third parties. It's not going to work out. It's really not going to work out. It's going to be a major nightmare once it's been implemented into big things like cars that is difficult to change, or you have Oyster where millions of euros, probably actually more than tens of millions of euros has been invested into this thing, and then it turns out it's all wrong. At that point, you have to tell your customers, your employees, it's just going to be a nightmare. Not only outside your company, inside your company, because of course people in your company are going to view themselves as having developed something that is all crap, and that's not going to be reflecting good on the people that work at your place, and then they'll be leaving you. So this is. It's a major nightmare from all points of view, from PR, from all of that, and it's best to work to the point of either using ciphers that have been known to be good, like for instance the French government uses DESX, if you know, in Navigo, so we cannot break it because they're using a standard cipher. This is actually a very good point, or a very good move from the French government, because almost everybody was using high-tech 2 and MyFair in most applications. So you can this kind of stuff with MyFair, you can use it in Beijing, you can use it in Sao Paulo, you can use it all over the place. You can go to America and use it. So this actually doesn't break London. It breaks half of the world in this sense, and it's really lots of public transportations are using this. And French doesn't use it. The French government doesn't use it. They're using Navigo and it's doing it well. So yeah, if you do it, if you do try to make your own cipher, then do ask other third people how well it is made, or use a standard cipher. Use a standard cipher. It's always a good idea. So I'll be taking a couple of questions. Thank you for your time.
Thank you.
What language is crypto miniset written in?
It's written in C++. I'm a lazy coder, I'm sorry. But the thing is, I do this on purpose, and the reason why I'm doing it this way is that writing it in C possibly would be faster, because this is sometimes we really go low level. I don't write assembly, sorry, but we can go really damn low. So I have my own, for instance, we have our own memory manager. I wrote that myself, but anybody could have written it probably. But so we write our own memory manager, but we don't actually use malloc. So there are stuff that is really down to low level where C would be perfect, but I like people to actually contribute. And when you go down to C and assembly and all that stuff, yeah, that limits the number of people who contribute, right? And on top of that, it makes it difficult to read the code. There are some code that is written in C. It was actually the second best in the set race. It was pretty interesting. It was the second because everybody thought it would be the first, but yeah. That one is written in C. And if you have a look, like the variables are difficult to understand because they're like 4 letters max. And yeah, so sometimes it gets really complicated to understand C code. Sometimes it's really well written, like kernel, right? So yeah, but I wrote in C++ because I'm lazy, mostly. But it works out, right? I mean, it works out. Eventually, it's not the really low-level stuff that's going to matter. Of course, it gives us, I don't know, 10%, right? But the real stuff that's going to make a big difference is going from ordo n to the power of 2 instead of ordo n to the power of 3. So, you know, instead of an order of magnitude is gained there. It's not, you know, you're not going to be gaining an order of magnitude using low-level assembly. You're not. I'm telling you. Yeah, you're not. It's going. Yeah, you can do bit slicing and I don't know what SSC instructions and stuff, but yeah, no. It does help, but not as much. Yeah, it should. Yeah.
So you mentioned obviously we have known good crypto. So why are there still so many companies using these weak ciphers, developing their own weak ciphers? What are their incentives? Is it hardware and power requirements, or?
It's very simple. You don't want other people to manufacture the same stuff. So you don't want a Chinese company making a clone of your stuff and selling it for $1, and you'll be selling it for 120. And it's a real problem. So they're trying. I think the original intent was first partially to hide the 48-bit key, which of course you can crack it on an FPGA in under a couple of days, weeks, probably weeks, I would say. It depends how many FPGAs you have. The French government can probably crack it in like less than a day or less than a minute, probably. But you know, it depends on how much hardware you throw at the problem. But yeah, it was. The 48-bit was a big problem, and the other problem was they didn't want anybody else to copy it. And of course, they didn't want to be ridiculed. I mean, you take a car that's worth I don't know 10,000 euros, and you're securing it with a 48-bit key. That's like having a sign on your open window. Please come in and take my stuff. Yeah, it's not. You know, everybody's going to laugh at you, right? And not only nobody's going to buy your product because it's all a joke, and then you're going to be ridiculed in the other industrial circles. So yeah, hiding, yeah. So we're trying to hide, yeah.
Can't you get the same sort of incompatibility by implementing a standard algorithm, but seeding it with the key that you don't give your competitors?
Now the problem is that it's so you can copyright yourself, right? You say, well, this is my protocol. You cannot implement it because I've copyrighted it, which works very well, except in China.
Well, no.
So that's the problem, right? I mean, have a look around. I mean, they're importing. I don't know. I just read X5s that look exactly the same like the X5, but they put a different logo. So yeah, it's copyrighted, but
no. That's not what I'm talking about. What I'm talking about is taking a standard algorithm and then modifying it slightly to take a non-standard key that you will be in possession of and your competitors won't. So
yeah.
If you need to break compatibility in a trivial way, break it in a trivial way.
Yeah.
By providing providing a piece of data, not logic.
It doesn't really work nowadays because multiple factors. But for instance, I just have a paper with a guy called Manuel San Pietro, who is a really nice guy, and basically he talks about this. So you have a DES or an AES or something, and you try to slightly modify. What they usually do modify is called the S boxes. there's some sort of function inside that you want to modify, and then you modify it, and nobody knows what's going on because it doesn't really work like an original cipher anymore. It's a slight change, but you don't know what it is, so you would have to reverse engineer and everything. And this guy just developed this technique to do this in like a day. So it's not going to work anymore. But yes, that could have been a way of doing it. I don't think it will be the way of doing it anymore, but we'll see, because even that kind of reverse engineering is called FIRE, fault injection for reverse engineering. So we inject some faults and then we observe the output and then we recover the S boxes. So yeah, it's not trivial to inject faults. It's not impossible, but you know, I think it might be a possible way of actually breaking a cipher. So it's getting less and less a possible way of doing it. But yes, you could. That answers the question, I hope.
Have you ever looked at
Yeah, we do.
Can you use a graphical representation of your algorithm to find similarities between hash functions, between block cipher, this kind of stuff? Or is it just for making fun in front of people?
No. It's here's the thing, and this is very deep. The problem here is that nobody understands what's going on. There's a set community, it's a lot of researchers, they're really brainy. I'm not inside them, but yeah, they're really brainy, and they have no, I would say they have no clue. They do say they have clue, but I don't think they do. So it's really difficult. It's really difficult, and it's not because they're dumb at all. It's just very difficult, and we're just trying to develop some visualizations to have a clue, to have something to grab onto. Because you have this kind of thing, right? You have these statistics printed out, which are really dumb and simple statistics. You could do much more, but yes, so that's all we have. And then you look at the statistics, you have absolutely no clue what's going on, and then you just solved it and you didn't solve it. Sometimes you solve it in 10 seconds, sometimes you don't solve it in 1 year. And sometimes people have absolutely no clue why. And they say, okay, well, we have this problem, it's got 20,000 variables, we can solve it, we're great. I can give you a problem that has 2,000 variables, if you solve it, you're the master of the universe. Yeah, it doesn't, the number of variables makes absolutely no difference, basically. So, yeah, we have no clue, and we're making these three-dimensional things just to have some clue. Three-dimensional, two-dimensional, right? That was the search tree as well. I believe we humans are visual people, so we like visual stuff. It's very difficult to represent this in our heads and say, okay, so this is a recursive search algorithm and it's doing something that is like that. But then you actually have the physical representation of that thing, and then you say, okay, so that's what it's doing, and then you have a bit more clue of what's going on. But still, of course, it's pretty difficult. That's the reason. It's not for entertainment of the crowd here. It's for the entertainment of myself and understanding of what's going on. I think it's more understandable, but still, it actually poses more questions than the answers. But at least it answers some. Any others?
Have you ever done work with Keylog?
Keylog?
Yeah.
Oh, that was Nicolas Courtois and all the rest. I think, and Gregory Bart, of course. Yeah, they're great people. I'm in regular contact with both of them, I would say. They've done great work in this field. I think cryptanalysis would be their candidate for using raking it.